In this video, we're going to be taking a look at the factor theorem. We're going to go over the factor theorem, and then we're going to do a couple different examples, a couple different applications of how you might go about using that factor theorem. The factor theorem states that if you are given f of x is a polynomial function, you're given f of x and it is a polynomial function, then x minus c is a factor of f of x if and only if f of c equals 0. Okay, so we know that then we could do a little test really easy. If I know that x minus c is going to be a factor, I'm going to take that c, I'm going to plug it directly into my function and evaluate it, and if I get a 0, then I know that x minus c is going to be a factor. Okay, and that's going to help us to factor something. If we have 4 terms or something's going to be difficult to factor, if we can find one factor very easily, but doing a shortcut like that, that's going to make the overall factoring a little bit easier. Alright, so in this example right here, it says use the factor theorem to determine if x minus 1 is a factor of the polynomial 2x to the third minus x squared plus 2x minus 3. Okay, we are going to assume here that this is our f of x, okay, so that we can just use that notation, okay, throughout this whole entire thing. Now, if you know how formulas work, since this says x minus c, alright, and this is in my given formula, basically I take the opposite of what I see when I pull it out and I start to use it. So right here, I'm seeing x minus 1, so then what I plug in as my c, I want it to be a positive 1. Okay, so real quickly, I could, assuming this is called f, I could say, okay, I'm going to evaluate f of 1. So that would be really simple here to do 2 times 1 to the third minus a 1 squared plus a 2 times a 1 and then minus a 3. That's going to give us a 2 here minus a 1 plus a 2 minus a 3, which gives us an overall answer of 0. Alright, that was a good thing. As long as I get 0 there, then I know this x minus 1 is a factor. If I would have evaluated that and got any other number other than 0, then x minus 1 is not a factor of this polynomial. Alright, so if we wanted to write a little conclusion here, therefore the binomial x minus 1 is a factor of the polynomial 2x to the third minus x squared plus 2x minus 3. Okay. So in that one, that's the only thing that it really told us to do, so we're not going to continue to factor that. Okay. Now, in our second example here, let's take this and apply it in a different way. Let's suppose this time it says to use the factor theorem to help you completely factor this polynomial curve, 2x to the third minus 3x squared minus 11x plus 6. Alright, given that 3 is a 0. Okay, so here again, they're emphasizing, okay, use that factor theorem. We know that. Here's my polynomial function. We're going to assume that that's our f of x function. And then it says, given that 3 is a 0. Alright, well, as soon as they tell you that 3 is a 0, alright, I can take this polynomial expression right here. Let's even go to a different color here. I can go to this polynomial expression, and then I know that since 3 is a factor, then, or 3 is a 0, then x minus 3 has to be a factor. Alright, and then times something else, another part of it. Alright, but the fact that 3 is a 0 tells me that x minus 3, again, that opposite sign, is going to be a factor of that. Alright, so if I know that, then what I'm going to do, I would probably, instead of trying to do a long division on this, x minus 3, into that to see what this is left over, I would probably go into a synthetic division because it's going to be a little bit quicker. So I'm going to take this 3 and I'm going to put it inside my box, and then I'm going to come up here for my synthetic division. I'm going to take all of those coefficients. So I'm going to do a 2 and a negative 3 and a negative 11 and a 6. Alright, this 2 always comes straight down, and then we add. Alright, so 2 times 3 is going to give me a 6. Add coming down, I'm going to get a 3. 3 times 3 gives me a 9. Add coming down, I'm going to get a 2. 2 times, or sorry, negative 2. Negative 2 times 3 is going to give me a negative 6, and I get a 0. Alright, which case we knew was going to happen because we know it's a factor. Alright, so I don't need this remainder. Alright, I'm going to take this and write this as my polynomial that goes right here. Okay, so this would be my plain number term. Here, let's do this in a different color. And then this would be my x term, and then this would be my x squared term. Okay, so that's going to allow me to create the polynomial that is going to be the other part of that. Alright, so this, what we just found, goes up there. Alright, so now I'm going to go all the way from the very beginning here. We started with a 2x to the third minus a 3x squared minus 11x plus a 6. Alright, I know that 3 is a 0, so that gives me x minus 3 as a factor. I then did long division, alright, and I got another polynomial right here, alright, of 2x squared plus 3x minus 2. So this original polynomial curve factors into this. Alright, now I need to see if I can continue to factor. Well, this is a binomial. It's not going to factor anymore. But if I look at just this right here, this is a nice little trinomial, and it is going to factor. So I'm going to keep this x minus 3 right there. And then I'm going to do a guess and check on this, which means I'm going to have probably a 2x and an x there. And then I need multiples, two things that multiply together to get negative 2, which is going to be my only choices of a 1 or a 2. And I think to get a positive 3 there, my 1's got to be minus and my 2's got to be a positive. That'll give me a negative 1, that'll give me a 4, and negative 1 gives me that positive 3 right there. So now this original polynomial that we had that had 4 terms in it, we have now factored completely into this, and we used that factor theorem to help us get started. Okay, so this right here where I did synthetic division, you would not have had to have done synthetic division. You could have done this as long division as well. You still would have come up with this 2x squared plus 3x minus 2. Alright, so just a couple different examples there of how you might apply that factor theorem. Definitely thanks for watching, and don't forget to subscribe to the channel. Thanks.